Hello friends, in this lecture I am going to discuss about synthetic methods for pyrrole. The different methods which are used to synthesize pyrrole are Nude synthesis, Palnor synthesis, Henderson synthesis and synthesis of pyrrole from furan. So Henderson's pyrrole synthesis. The Henderson's pyrrole synthesis, name for author Rudolf Hendes, is the chemical reaction of beta ketoester with ammonia or primary amines. So these are two starting compounds that are beta ketoester with ammonia. So this is a reaction in between these two reagents and alpha haloketones to give substituted pyrroles. And pyrroles are found in a variety of natural products with biological activity. So, the synthesis of substituted pyrroles has important application in medicinal chemistry. Alternative methods for synthesizing pyrroles exist, such as Nude synthesis and Palnor synthesis. So, these two synthetic methods are alternative methods for synthesis of pyrrole. So in this Henderson's pyrrole synthesis, the important compounds are beta ketoester with ammonia and alpha haloketones. So the first structure is of beta ketoester. Then it reacts with ammonia or primary amines and alpha haloketones. This is an alpha haloketones, in which halogen is present and at alpha position chlorine group is present in this structure, that is halo group, and this one is carbonyl group, which is very important for the reaction to proceed. Then in presence of this NH3, its primary amine, it gives pyrrole, which is substituted at 1, 2, 3 and 4th position. Now second reaction, that is Palnor synthesis. So this synthesis takes place from 1,4-dicarbonyl compounds and ammonia primary amines. So these are the two very important starting compounds, which are 1,4-dicarbonyl compound and ammonia or primary amines. Pyrroles are formed by the reaction of ammonia or a primary amine with 1,4-dicarbonyl compound. Successive nucleophilic additions of the amine nitrogen to each of the two carbonyl carbon atoms and the loss of 2 mole equivalents of water represents the net course of the synthesis. A reasonable sequence for this is shown below, using the synthesis of 2,5-dimethyl pyrrole as an example. So, synthesis of pyrrole from Palnor synthesis is given by giving the example for the synthesis of dimethyl pyrrole. So this one is 1,4-dicarbonyl compound which reacts in presence of CH3COH to give the respective pyrrole, which is substituted at 2nd, 3rd, 4th and 5th position. R group may be varied. It can be RH, can be CH3 or COC2H5, and R dash group can be COCH3 or COC2H5. Synthesis of pyrroles from 1,4-dicarbonyl compounds. There is 1,2 and 1,5 bonds made. From this reaction, these two new bonds different. The most obvious route to pyrroles involves the introduction of ammonia or a primary amines with 1,4-dicarbonyl compounds, the Palnor synthesis. Then successive intermolecular and intramolecular nucleophilic additions. Okay, initially intermolecular reaction and then intramolecular nucleophilic substitution reaction takes place. In this addition reaction of ammonia or amine nitrogen to the two carbonyl groups followed by loss of two molecules of water and finally tautomerism lead to the aromatic new molecule. So this tautomerism is very important, which leads to the formation of aromatic molecule. So this is a mechanism of pyrrole synthesis, which is 1,4-dicarbonyl compound in presence of NH3. Okay, and reflux condition. NH3 attacks at first position. Okay, after that there is a cyclization reaction. After the cyclization reaction, there is removal of one water molecule. After the removal of water molecule, these two intermediate products will form. After that, tautomerism to aromatic structure. After the tautomerism effect, okay, that shifting of hydrogen. Okay, so from fourth position, hydrogen shifts towards nitrogen. That's why new bond is formed between nitrogen and hydrogen, and double bond changes. The new bond is formed between 4 and 5. So this is a new pyrrole which is formed. It is 4,5-dimethyl pyrrole. It is 2,5-dimethyl pyrrole. From alpha amino carbonyl compounds and activated ketones. So this new synthesis is carried out in presence of alpha amino carbonyl compound and activated ketones. So alpha amino ketones reacts with carbonyl compounds that have an alpha methylene group in synthesizing pyrrole. So this reaction is known as an pyrrole-Noor synthesis. Mechanism of Noor synthesis is widely used general approach to pyrrole utilizes two components. One is alpha amino carbonyl component supplies the nitrogen and C2 and C3, and the second component supplies the remaining two carbons and must possess a methylene group alpha 2A carbonyl. The Noor synthesis works well only if the methylene group of the second component is further acidified to enable the desired condensation, leading pyrrole to complete effectively with the self-condensation of alpha amino carbonyl component. So this is an overall mechanism of Noor synthesis. Then alpha amino ketones reacts with carbonyl compound that have an alpha methylene grouping, synthesizes pyrrole. So these are the two important reagent condition that aqueous KOH is required, and these two, that is alpha amino ketones and carbonyl compounds. So this is an carbonyl compound and this one is an alpha amino, that amine group is present at alpha position, alpha amino ketone, and this is a carbonyl compound. So it reacts with each other in presence of this aqueous KOH and gives this product. So the synthesis of 4-methyl pyrrole. So in this reaction, after reflux of 24 hours, it gives 60% deal and gives 4-methyl pyrrole, carboxylic acid. And after distillation, this carboxylic acid, due to the removal of this QOH group, it gives 3-methyl pyrrole. So in final step, there is a conversion of 4-methyl pyrrole, 3-carboxylic acid to 3-methyl pyrrole. So this is a reaction which gives 73% yield after distillation reaction and removal of one carboxylic group. Then synthesis of pyrrole from furan. Pyrrole could be obtained by following reaction. That pyrrole could achieve by treating furan with NH3. So this is a reaction of furan with NH3 at 753 to 763 Kelvin in presence of aluminium with removal of one water molecule and forms pyrrole. So this furan in presence of NH3 removes one water molecule at 753 to 763 Kelvin temperature. In presence of aluminium, it removes one water molecule and forms pyrrole. So these all are the methods, synthetic methods, which are used to synthesize pyrrole. Then in presence of Al2O3, if you are going to use just NH3, then you will get pyrrole, and if you will take alkylamine, okay, if you are taking R group along with NH3, then you will get substituted pyrrole at first position. It is on nitrogen. Okay, so based on your reagent condition, you will get a final product. If just NH3, then you will get pyrrole, and if you are taking alkylamine, then you will get fictive pyrrole substituted at first position with alkyl group. Thank you.